Okay. Well, the first thing I should make clear is that the book may appear to be part of the current trend. There's been a proliferation of popular science literature and other media. A lot of books in circulation which are trying to effectively promote or generate a certain amount of excitement or enthusiasm about mathematical or scientific discoveries, and I'd like to sort of separate myself from that, because this isn't simply an attempt to promote mathematical ideas as something everyone should be interested in, or that is somehow very important or exciting. The project was motivated by the philosophical implications of what I was finding. I didn't specialise in number theory in my academic work. I sort of left academia some years ago and then found myself back in sort of re-entering the world of mathematical research some years later, mainly because there seemed to be some strange philosophical implications associated with what was being discovered about the distribution of prime numbers. And after years of creating and curating and expanding an online web archive which deals with this from a fairly high-level academic point of view, various people urged me to try and to create a more accessible version based on my seeming abilities to be able to explain some quite difficult ideas to ordinary people. This seems to have come about because most of my friends are not involved in the mathematical sciences, and just based on wanting to explain what I'm doing to my friends, I've developed a repertoire of techniques and visualizations and metaphors which seem to work to explain some fairly difficult ideas which are normally considered inaccessible to non-mathematicians, but with a bit of imagination and effort I've found that you can actually get a lot of these things across. So basically driven by the desire to bring some very important philosophical questions into public discussion, I've set out to self-publish this trilogy. I mean, I could get into the details of what these philosophical issues are, but that would probably take quite a while.
Well, you mentioned the distribution of prime numbers, and this is kind of at the core of it, isn't it? Could you just explain what you mean by the distribution?
Okay,
what's the core problems that produces these strange and mysterious patterns?
Well, most people would have learned what prime numbers are at school, and some of you will have forgotten or may just about remember, but probably won't remember why it was important or can't see why it would be important. Prime numbers are those counting numbers which can't be divided into smaller, can't be divided, they're indivisible. The simplest way I can find to explain it is in terms of just a pile of beans or a pile of pebbles. Some piles of pebbles can be divided into smaller piles, so 20 pebbles can be divided into 4 piles of 5 or 10 piles of 2, 21 can be divided into 3 piles of 7, 22 can be divided into 2 piles of 11, but 23 pebbles is just 23 pebbles, you can't do anything with it. And what's interesting about this is it completely transcends anybody's opinion, anybody's culture. It doesn't matter what symbols you use to write the number 23, you can write it in Roman numerals, binary, Mayan hieroglyphs, or anything you like. It's one of these inarguable truths that some numbers represented as a pile of similar objects can be subdivided and others can't. So it seems a fairly straightforward matter to then, for example, write the numbers along a line in the way that you may remember from mathematics lessons. Just create a number line and mark out the numbers which can be subdivided and the ones which can't. And if you start doing this, one of the first things you notice is there's no obvious pattern, there's no regularity in it, it looks completely arbitrary. And yet, it's just there, it's just coded into the nature of reality. Unlike almost anything else you encounter in the world, this is, as I said, it transcends opinion or culture, time, space. You could almost imagine replacing the entire contents of the universe with something else and it would still be true, and there's not much you could say that about. You could even imagine the laws of physics being different. So we're looking at something really quite fundamental in the truest sense of that word. And bearing in mind that number is the sort of interface whereby we comprehend the world and break it down into categories of similar things which we can name and then talk about and manipulate. So this irregularity in the sequence of prime numbers creates a sort of unease in that people sense there's something. Yeah, they can see that if you display this sequence visually, people can see it's not regular, and yet they feel it should be, because we're so used to. Well, mathematics sort of, in most people's minds, is associated with a sort of order or regularity or an ability to pin things down in that sort of way, and yet it defies that. And that defiance is the starting point, really. So mathematicians have been struggling since ancient Greek times to try and make some sense of this, and there's been an accumulating body of theory which goes on, which has there were certain watersheds in the mid-19th century where certain things were discovered, which I discuss in the book. But effectively, we're still a huge distance from really understanding what we're looking at here.
Just on a point of information, are you saying then that if you project the sequence of prime numbers however far you want,
yeah,
there are no predictable or recurring sequences of intervals?
That's right, exactly. In a way,
so it's a phenomenon in a sense.
It is, and it's the absence. I mean, it's almost the inverse negative image of regularity, because you've stripped out all the regularity. You remove all the even numbers, you remove all the multiples of 3, you remove all the multiples of 4, 5, 6. So anything that you associate with rhythm or regularity has been removed, and you're just left with all these holes. And the holes make this jumble, this messy looking pattern. And this has been troubling the Western psyche, which wants to sort of nail everything down conceptually. And generated this, as I said, this huge proliferation of very, very difficult mathematics. At one level, you're just dealing with counting numbers, you're dealing with a concept you can explain to a 7-year-old, really, just playing with pebbles, and yet the world's best mathematicians have been banging their heads against the deeper problems at the heart of this matter for centuries, millennia, and really just getting more confused in some ways. If I were to show you what some of the mathematical research actually looks like in terms of how it's presented, it's horrific. I mean, the whole reason for this book is to try and gently bring people into this discussion, because if you opened up a book about the theory of the Riemann zeta function, it's just aesthetically very displeasing, and it looks like some sort of alien language, and you have to be initiated into it. You have to dedicate years of your life to be able to understand even some of it.
So essentially, there's something very fundamental about reality as understood through the number system, which is one of the most important ways we understand reality. There's something very fundamental which is unknown, and which all of the research which has been done about it only deepens the mystery.
That's exactly
and
it.
And it's this mystery that you're trying to get across to a general reader, but also you have your own hypotheses, which perhaps we can discuss later, about the nature of this mystery and its implications for not only for mathematics, but also for wider social implications, because the way in which we understand number has an impact on the way in which we understand the world. So I'll turn to Conrad now. It's very interesting that Matthew ended up talking about the aesthetic dimension of mathematics, and the fact that if you open up a mathematics book, you're unlikely to be seduced visually. And he was also talking about his trial and error kind of way in which he's developed a repertoire of techniques and ways of visualising and metaphorising what he's talking about. And Conrad's work, I think, has also this element of visualising the unvisualisable. And that, in a way, would describe best its relation to scientific and philosophical concepts. Would you agree with that?
Yes, and I think definitely. I think it's quite a different approach, but we share some similar motives, me and Matthew, in the sense that we are trying to visualise these invisible aspects to it, and we're reliant on a certain amount of sort of metaphor and kind of and sort of ways to communicate an idea.